So I'm recording on this computer. So guessing game. I'm gonna go through the process. I'm gonna fork it over to my machine. I'm gonna clone it or fork it over to my GitHub. I'm gonna clone it down to my machine. I'm gonna check out a new branch, and then we're gonna work off that branch. Depending on time, I'll also create some test specs. I won't be doing TDD today. I'll just kind of solve it, and then I'll go back and do some write some unit tests for it. All right. So first thing I'm gonna do, I'm in Platoon GuessingGame GitHub. I'm gonna fork it over. I'm gonna come down here and fork to Tom Preet. I've been having some issues with GitHub on Chrome past couple of days, so we'll see if everything works out. If not, I'll have to do it in Firefox or Safari. But all right, cool. Forked over to Tom Preet GuessingGame. Now I'm gonna git clone it by going to the green code button, HTTPS, click that button, it copies it. I kind of don't like how it doesn't say like copy, so I always kind of double check it and copy it. I'm gonna open a new window in VS Code. I'm gonna open my terminal by doing Control tilde, and then I'm gonna CD into my desktop, code Platoon, is it code Platoon? Let's actually see where I have it. I'm going to list everything out. CP challenges, so that's where I keep all my challenges. Oh, CD into CP challenges. Platoon challenges. There we go. There I've got some challenges that I've already completed. Now I'm going to git clone it down. What's the command for git or cloning it down to my machine?
GIT space clone, and then the URL.
And then paste in the URL. There, I've cloned it down. I'm going to list everything out into my current repository. Got 99 bottles, and there's my guessing game. So I'm going to CD into my guessing game. I'm going to actually zoom in a little bit. Oh, that's a lot. That's good. Now I'm going to reload VS Code and open this in the current window or in the current Explorer. So here's my guessing game. I'm going to open up the README, opening up the guessing game. I'm going to close the Explorer, and I'm going to split this. So I've got my guessing game on my left, and I've got the README. So this challenge will help you to break down problems into implementable pseudocode, implement a basic Python class, and identify when to use instance variables, use control flow and flow control and iteration where appropriate, explain how instance variables and methods represent the characteristics and actions of an object. Cool. So let's create a simple guessing game. Think in terms of when you're 7, you asked a friend to identify the number you were thinking. Your guessing game class should be initialized with an integer called something like answer or answer number. Okay. So let's just do some pseudocode. All right, so the guessing, this is all pretty much pseudocode right here. It just tells us how to do it. So I'm just gonna kind of translate this into pseudocode. So our guessing game class should be initialized with an integer with something like answer number. So I'm gonna say initialize the class with an answer number instance variable that stores the answer. Kind of makes sense. So this is the number that we want the user to guess. So this answer number, all right. And then it says define an instance method, guessing game. So guess, that's the instance method we have to define. So it just says hashtags and documentation. What we're reading right now is the documentation. Generally means that it is a method. So this hashtag guess is a method. So it kind of says, in our case, guessing game has a method called guess, which takes in an integer called user guess as its input. So we can say, create a method named guess, which takes a user guess argument. All right. Then, so which takes an integer called user guess as its input. And guess should return a string of high if the user guess is high or is larger than the answer. Correct if the user guess is equal to the answer, and low if the user guess is lower than the answer. This is like exactly the pseudocode that we should probably be writing. Guess should return high or low string if the user has guessed too high or too low. Or return correct if the user guessed is equal to the answer number. So if the user guess is equal to this answer number that we initialize the class with, then it will return correct. And it should be a string. Great. And where does it say? Okay, I think that covers that part. And then it says define an instance method called solved, which returns true if the most recent user guess was correct and false otherwise. So this is where it's like, okay, so we have this solved method, which is going to return a Boolean value, whether or not we solve the answer or not. So there we have to store a Boolean value somewhere of whether or not we have the guessing game is solved or not. So I'm just going to say create a method solved that will return true or false whether or not the user guesses the right number. I would say answer number. But we don't like have a way. So if we just call solved, we have to have something that checks whether or not the user has guessed the correct answer. So this is where it kind of gets a little difficult because we're not storing, like there's nothing in here that tells us how to do that. But what we can do is declare another instance variable in the dunder init method called like is solved and set that to an initial value of false. Because when we initialize a new game, we haven't solved the game yet. So it's not solved yet. So it would be false. But once we start playing it, once we get the correct answer, we have to do something that changes this is solved method or is solved instance variable to true. So with that, we can kind of go back. So I'm just reading this down here. At what point in our code or in our pseudocode can we change this is solved instance variable to true?
Once the player guesses the right answer.
Yep. So guess should return high or low if this high or low string if the user has guessed too high or too low, or return correct if the user guess is equal to the answer number. So maybe or return correct. So I'm just gonna in here return correct. So in this like logic, so return high. Should break this up, should return high. if the user guess is greater than the answer number. And then likewise with low, if user guess is less than, greater than, is less than the answer number. So I could say create a guess. I guess there we go. And then in here, when it returns correct, we can also say returns correct, change, or I would say reassign is solved to true, and return correct if the user guess is equal to the answer number. So that looks like our pseudocode for this class. And we can kind of come down here and have some examples. We have some driver code. This driver code could get a little tricky if you deviate kind of from what is expected. But if you use either or, it's fine. So let's go ahead and create our guessing game class. So initialize the class with an answer number instance variable that stores the answer. So how do we initialize a class that accepts an argument? What method do we need to use?
The dunder init.
The dunder init. And what does this method do?
It runs upon the creation of the object.
Yep, it runs on the creation of this object, or when this object is instantiated, when it's first initialized. We always pass in self pretty much in every case, except for there's other cases where it might not pass in self, but in most cases we do. So we need to initialize with an answer number instance variable. So this needs to take in an answer number. And now, how do I create an instance variable?
Self.answer number equal to answer number, or whatever you want to call it.
Self.answer number equals to this argument or this parameter that we're going to be, essentially this parameter. And what is an instance variable? How does it differ than a local variable versus a class variable?
It's unique to the object versus a class variable, which is unique to everyone in the same class.
So an instance variable is unique to the instance. Is that what you said?
Yeah.
And a class variable is accessible throughout every single instance of that object. And what is a local variable?
Something that's written under or inside a functions block. Or a local variable is just something that is only unique to the block. So once you go outside of the block, the variable you're using will no longer store its value.
Yep. So instance variable with the self appended to it, we have access to this variable throughout the entire instance. So in any other methods we write, we'll have access to the self.answer within those methods. A local variable is a variable that doesn't have the self appended to it, and we only have access to that variable within the scope of that method. So we don't have access to that variable in other methods within the class.
Tom, what are
Yep.
some? Are there any alternatives to self? Like if you had another game, say, and you wanted to call a function from that other game, would you call the other game instead of self, or how? Like, is that sort of the point of object-oriented programming? Is that you can build this thing here and then call it somewhere else?
So let me see if I understand. So we have two games going on at the same time, right? And you're asking the self. Yeah, I'm trying to.
Like if you have a chess game that you built somewhere else, and you only like why self? How is this different from Def Grandma, where we built a function and then created some rules underneath it for if the user guesses this, then return this, and we didn't have any selfs.
So think of self is referring to like literally this yourself. That's how I think of it. Like a guessing game is like if you have like a tabletop game like chess, if you refer to self, you're referring to that instance of that game. So, and you can have multiple games going on at the same time, but one game's self, like chess piece, might be a different, like the location of one game's chess piece might be the location of one chess piece in one game will be different from like another game. So the self keyword refers to that instance of that individual game. So you can have multiple games going on, but the self keyword refers to that only one of those instances of the game.
So is there another keyword then for that you would use to refer to the other instances, or is self the only thing that ever goes in front of that?
No. So if you want to access the other instances, that's where you come up with a class variable. So a class variable would be like up here, like some variable, and now like 5 or whatever 6, and now I'll have access to this class variable across all instances of that game.
Of guessing game.
Yes, of guessing game.
Okay.
Correct. Yep, and we'll get to that later on when we do some more OOP review.
Okay, thanks. Sorry.
Cool. No, you're good. So initialize the class with an answer number instance variable that stores the answer number. All right, declare another instance variable in the init method called isSolved and set that to an initial value of false. So self is solved equals false. So let's just come down here. I'm going to say like new game and instantiate a new guessing game with like 50. I'm just going to run this, and I'm actually going to do print self.answer number and is solved. So I'm going to open up the terminal. Whoop. Come up here and list everything out. And now I'm going to run guessing game. And if I run this, it's going to come down here. It's going to instantiate a new guessing game, inputting 50 as the answer number, assigning the answer number to self.answer number instance variable, also creating a self.isSolved equals false, and then it's going to print the answer number and the value of isSolved right when I execute this code. So 50 right here on line 15, and then false line 16 right there. Does anybody have any questions about what I just did with regards to the dunder init method, and then how do you actually instantiate or initialize a new guessing game? So I'm storing this new guessing game instance into a variable called new game. And now if I want to just print new game, see what this looks like. So I took out this print statements, so nothing should show up here. But now I'm going to print new game. I just want to see what that looks like. So we have Dunder main. It's a guessing game object. So that's why it's called object-oriented programming, because all these classes, it's a class object. And it's got this is probably like the location where it's stored in memory. But yeah, so there's the guessing game object. And I also want to show you, if I type in dir, I think this is directory, and I encapsulate this new class, this guessing game object in dir, it should print, let's see what it looks like. It just printed an array of all the attributes associated with this class object. So in every single class object, it has all these attributes, these Dunder methods. These Dunder methods come included with every class object. So we got doc under Dunder format. There's our Dunder init over here. We also have all these other ones. Most of these I don't even know what they do. We'll get to what this REPR means later, and this Dunder string. But notice how once we get to the very end, we have answer number and is solved at the very bottom. These are additional attributes that we added to this class object. So if you ever want to know what attributes are added to a class object, you can just do dir and encapsulate that instance with it. All right. Does anybody have any questions? All right. Let's continue. So it says declare, it says create a method named guess, which takes a user argument called user guess. All right. It says return high if the user guess is greater than the answer. I just want to make sure I explicitly tell you what I'm actually returning. All right. Cool. So now I want to create a instance method called def guess, taking the self keyword as always as the first parameter or as the first argument, and then user guess. And now it says like if user guess is greater than self dot answer number. So again, I have access to this instance variable in all the methods throughout the class or throughout the instance by just calling self dot answer number.
Hey, Tom, quick question.
Yep.
So the instance variables, so if you want to assign a new variable under, say, guess, you could do self dot variable name equals whatever. But if you're just, and that would be available to every single method in the class, right?
Yes. However, so if I wanted to create another instance variable called like some var and assign it to 6 again, I would only have access to the self.someVar after this guess is actually executed.
Okay.
But whereas anytime I initialize a new instance, it automatically creates these. So I can actually.
Oh, I see. Okay.
So return hi. So let's actually kind of run that. So if I want to access new game dot answer number, I can I'm clearing the screen down here in the terminal. Now I'm going to run that again. So there's 50, but now I say I want to access this some variable, and I do new game some var, and I execute that. It throws an error because it has this instance variable hasn't been created yet.
So the best way to if you're going to use something, you think be returning something that's important from the class, then the best way to do it is initiate it in the init method, you think?
Not if you're just returning it. So if you want to access variables throughout different methods in the
method.
class, then you should. It's not 100. It's not like 100%. You should initialize it in the init method, but like more often than not, you'll want to initialize all the instance variables within the init method.
Okay.
But it's not like you have to.
But once guest has been defined, then you have access to it from that point forward.
Correct. So as long as you ensure that the logical flow of your class and how you're executing methods or instance methods, then you can create instance variables within other methods if you want.
Okay, thank you.
Okay. All right. Return high if the string is greater than. Then it says return low. So I'll do an elif. User guess is less than self.answer number, return low. And I can do else. So at the very end, so I'm in this block, it says reassign is solved to true. So I could say is solved is true now, because if it's not high, if it's not low, then it must be correct. So I'm reassigning this self.isSolved instance variable to true down here. And then return low correct. All right, so let's clear it. And now I can print, let's just run through new game dot guess. So this is the instance, the class object now. So now in order to access or execute or invoke this instance method, I grab the instance, which is a variable called, or it's called new game dot guess, and I can say like 77. I'm gonna wrap that in a print statement. And then I'm gonna do like 40. And so this first one should print high. This guess 40 should be low, should return low. So I'm gonna go in the terminal and run guessing game. I initially get high, so new game, guess, input 77, come up here, 77 gets put in user guess. Is 77 greater than answer number, which is 50? Yes, then return high. Do I invoke another guess method by passing in 40? 40 comes up here. If user guess is greater than, nope. So it comes down here into this block. User guess is less than 50, return low. And now I can also just print whether it's solved yet. Print new game dot is solved. And I'm not invoking inSolve because it's an instance method, so I can just access all the instance methods by just doing calling dot is solved. So if I run that again, I get high, low, false because I haven't solved it yet. But it's never good to access instance methods by doing dot is solved. You should always have a method that accesses them. So that's where this last part comes in. Create a method solve that will return true whether or not the user guesses the right answer. So I can say def solved, pass in self. Does this take in any arguments? Nope, it doesn't. So all I have to do is pass in self. And then here I can literally just return self.isSolved. So instead of directly accessing this instance variable is solved, I can execute the solved method. So dot solved, and I need to invoke it like that. And I'm down here in the terminal. I'm going to clear the terminal just to give us some more room. And I'm going to execute that again. High, low, false. Now let's actually solve it. Whoop. Now I'm going to actually guess the right answer, which is 50. Clear it again. Whoop. High, low, false is, and then correct. Now I can execute solved after I execute the correct answer, or guess the correct answer. High, low, false, correct, true. Great. So I can even just copy this code up here, run that. Let's see. I'm going to highlight all that. I'm going to create a bunch of print statements. And there we go. Now I can run this just to see if it matches what the expected output up here is. So false, low, high, false, low, high, false, correct, true, false, correct, true. All right, looks like it's working so far. Let's try this driver code. So I'm going to copy this. So I also need to import random at the very top. Just import it on line 8. Let's see if this works. So this driver code, you'll see it a lot going forward. This is just like a way to keep your program running to make sure, like essentially to make like an actual application. Enter your guess. I'll do 50. Uh-oh. It says trace back, guessing game line 41. Going into line 41 right here. Says type error greater than, not supported between instances of string and int. So I'm trying to compare a string and an int, so integer. So what's wrong with this? Why is this
It's turning
happening?
your input.
I'm sorry?
When you put in an input, it's stored as a string rather than an int, even if it's.
Yep, so inputs in the terminal, like right here, always get stored as a string, regardless of whether or not I put a number in. So this enter your guess, I typed in 50, it stores 50 as a string. So I could either change, I can do some logic in here to make sure that my answer number is an integer, or I can change it here. It's not really that important of where you do it. But you could put some logic in here to say like, hey, check, you can create like another method to check, hey, like def check if like the input is a number. But let's say we're pretty smart. We're never going to input a string. So that's just an assumption I'm going to be making about this game. So I'm always going to be inputting a number. I'm never going to be inputting a string like, hey, guess a number between 1 and 100. I'm never going to guess like orange. So up here, I can either change it down here. I can literally change our input into an integer like that. So if I execute this again, I type in 50, there, it works now because I'm changing this last guess, which is initially a string, into an integer when I'm passing it in to the game guess method, or the guess instance method. So your last guess was 50 was too high. It's too high. Cool. Guessed it in 3 answers. All right. Now let's actually create some unit tests. So I'm going to delete all that. I don't need this random anymore. So I'm going to list everything out. I've got guessing game, but I need to create a guessing game spec file. Spec.py. And I'm going to code guessing game spec. So I've got it right here. I'm going to grab the spec file on this right side. And so I'm going to create import unit test. And now I need to, from this guessing game py file, guessing game, import the guessing game class. So, and I actually don't need these little things here. So everything should still work. So from guessing game, import the guessing game class. So in order to create a new unit test or new, unit test, I'm going to say guessing game test case. And then I'm going to inherit the unit test case class. So I'm going to create some unit tests. I'm going to just do test returns hi, self, and then I'm going to just put in some comments. So when a user guesses 20, it returns low. So I should say self.assert equal. But I can either create a new game, say like new game dot new game equals guessing game and pass in 40. I can say like I'm gonna do self because this is, no, I don't think I need that. So I can say new game dot guess 20 should return low. Right, so I'm just gonna run this and see if it works. Python. Uh-oh, what happened? Did it run? What did I forget to do?
If name equals main.
Yep, at the very bottom, if dunder name equals dunder main unit test dot main. Whoop. There we go. So I'm down here in the terminal again. So one test ran, great. And I can also do the green guessing game spec to get a little more color. So I'm gonna clear it. So now I just kind of want to replicate this. Let's do it like, I'm gonna do another self assert equal, whether it's solved or not. Solved. So I'm just gonna just test two of those. Initially it's gonna be false. Cool. Now if I run that again in green, one test ran. So I'm actually like testing two things in here in this individual unit test. So it returns high. There we go. So returns low. Oh, wait, so this one should be low, right? Turns low. This one should be high. So I'm going to say 50 returns high. Input 50 in here. So if I run and then returns correct. So if I actually guess the right answer. So 40. Correct. And now the solve should be true. So if I run that I got 3 tests running and 3 tests passing. But there's something that's not that efficient here, in that I'm creating a new instance inside of each test. So the Python unit test library, let's see where it's at, has a setup method that executes before each individual test is ran. Wait, is that it? Setup, oh, right here, yeah. A method called to prepare the test fixture. This call is called immediately before calling the test method. So before each test is ran, I can call a setup method and set up each test. So I can literally say def setup. This is a built-in method inside the unit test library. I can say self.newGame equals GuessingGame and 40. And so this is executed before each unit test. So in here, I can actually get rid of these ones, but this is an instance variable now, the self new game. So in order for me to access that, I just have to put self before the new game. So if I clear in the terminal and run this again, everything should work the same. So if you want to set up or execute a function or a method before each unit test, there's a setup method. What questions do you have about this unit test? I just kind of wanted to show you how to import a class in the unit test spec file, how to use the setup method, which is literally just called setup, and then how to execute your class or your instance methods inside of each unit test.
Hey, Tom, I've got a question.
Yeah.
It's for the in the guessing game class under the guess method. Would there be any reason to ever put self.userGuess equals userGuess, or like we did?
Not self.userGuess equals userGuess.
Yeah, would there be any reason to put that, or could we just leave it without that?
Yeah, there's no reason unless you want to access this self.userGuess instance method in some other method outside of this guess instance method. So if you create
I would
like
only be able to be reached after the method's called, right?
Correct. Yep. Like, for example, if you just wanted to store all your methods, well, yeah, never mind. I was going to think of like if you wanted to store all your methods in an array or all your guesses in an array, but that still wouldn't be a good use case for this.
Okay, thanks.
How would you test for if you use the random number generator?
That would be difficult because every single test would essentially be different. So I would not use the random. Are you talking about if you put in a random number in here?
Yeah.
I'm sorry, you kind of broke
Oh,
out.
I see. So, oh, I see what happened. So you take out the driver code, so it's not generating the random number, and you're putting in the number manually. Is that?
Yeah. Yep, that's what I'm doing here. Yep. All right. Any last questions?